Hi, we're Ellen Way and Harshini Bulusu from Coxwell High School in Concord, North Carolina, and today we're going to be talking to you about our research on the effects of caffeine and melatonin on zebrafish juveniles.
Did you know that 83% of US teens use caffeine regularly, with melatonin tripling in the last decade? With adolescents increasingly relying on these substances for energy and sleep, we wanted to investigate their effects on learning. Caffeine can cause anxiety, heart issues, and sleep disorders, while melatonin has been linked to hormonal imbalances, dizziness, and even mood swings. So we used juvenile zebrafish as a model, and we tested how moderate doses impact their learning. We hypothesized that caffeine would speed up learning and make it more sporadic, whereas melatonin would slow it down. With overconsumption on the rise, our research also sheds light on how these substances can affect cognitive development. Understanding these risks can promote healthier choices for better learning, focus, and overall well-being.
So we wanted to know, by what magnitude does the consumption of caffeine and melatonin impact a juvenile zebrafish's learning trends? So we had 3 tanks. We had a control tank, a caffeine tank, and a melatonin tank, and the dosages for all of these drugs were determined using other research papers about physiological responses. So we had 15 zebrafish in each tank, and we also relied on automated systems for nearly the entire experiment so that we would minimize environmental stressors and allow for the best results. Now, essentially, we built an automated learning system that when the light flashed red, the food would dispense. So we were trying to get the zebrafish to respond well to the red light and move towards it, thereby having a learning behavior. Now, we also had a green light, but when the green light flashed, nothing happened. And this was so that the zebrafish weren't just attracted to the light, they were attracted to the red light specifically. We also had automated camera systems that recorded every single time the lights turned on, which allowed us to gather data more easily. And then finally, we ran our data through some machine learning object detection stuff in order to help us with the findings. Now, because of some errors, we weren't able to 100% rely on these, so a part of it was also manual analysis, but we also used that quite a bit. Now, in terms of results, we found that both the caffeine and melatonin slowed down their learning curves. However, the melatonin did so more, and this makes sense because of its sedative properties. Now, the caffeine made their learning really erratic. So we found these interesting patterns where essentially they were doing well throughout the day, but then the next morning they would do terribly. And we reasoned that this may be because it impacts their long-term memory. So in the nighttime period where they aren't constantly being reinforced with the behavior, they almost forget it.
Our errors consisted of, number 1, the Arduino feeding system, which often led to timing inaccuracies. Our second error includes the low-resolution tracking with the NVIDIA Jetson TX2, which may have caused the fish behavior analysis to be inaccurate at times. Furthermore, the schooling behavior of the zebrafish could have led to results that are indicative of a group of zebrafish rather than individual cognitive behavior. Our results show our hypothesis of caffeine making learning time more sporadic, whereas melatonin slows it down. Now, future applications could consist of using smaller fish groups, increasing trials, and enhancing automation for precise tracking. Furthermore, more studies could also be done to test more compounds and extend to larger model organisms, and to develop a predictive model to measure human cognitive effects.
Thank you so much for taking the time to listen to our research, and we hope you have a wonderful day.